Good morning and welcome to Rudy's Electronics Lab. And today I'm going to try to add an option to the CMU200 that I got over here. And this is the IQ option for that machine. Now you might have seen several earlier videos that I posted where I already been addressing IQ and generation of IQ signals and testing a IQ test kit. And I'm kind of excited in trying to add IQ capabilities to the CMU device. I think that would make things quite a bit more flexible. And also the way in which the CMU allows these new IQ options to be routed actually would allow in a number of different new possibility basically to connect to other equipment. So let's go and investigate that a little bit. So I purchased the IQ board for this machine via eBay. We got it over here. As you would expect from Rohde & Schwarz, this is a very sturdy unit, heavily metal all around. There are about 23 MMCX connectors here on the top, which will configure the RF side of the device. There's huge connectors down on the bottom, as it is with any of these cards. Something that some of you might or might not have seen yet, that the CMU has quite an interesting internal thermal management. So actually you have to open a little opening in the device when you enter this, and that will allow the airflow to go exactly through here and exactly to exit here. A very well thought out design, and if you look at the CMU from the side, you will actually see like all the cards that are installed there have their own kind of thermal path through the device and can get rid of their heat, because there can be quite a lot of energy being dissipated in the device. I took a close look inside. And there you actually see the electronic for the different IQ channels. There are four quite identical or close to identical electronic blocks here for IF to IQ conversion and the other way around. And everything, as you would expect, is shielded, RF shielded in a very proper way, as you would expect with Rohde & Schwarz equipment. So now what do we get if we add this additional unit here to the CMU? We would get 8 IQ in and outputs, 8 sockets. Well, as I'll show you in a moment, there's not separate sockets in this case. You get 4 intermediate frequency I/O extra connections. And if you look at the actual functionality, the IQ functionality supports all of the 2G and 3G functionality in that the device can have. So for 2G it's like GSM and GPRS, Edge and HSCSD. For 2G it can also be TDMA, known as DMs or IS-136. For 2G it can also be CDMA1. 3G can be wideband CDMA, also known as UMTS, and 3G it can also support a CDMA 2000 standard. Now all these standards basically are supported by this particular board. The board does not support the amps standard that you can have on this device, which is kind of logical because that does not use digital modulation or complex modulation in the first place, and it doesn't support Bluetooth. Don't know exactly why, but it might be that it's out of the range of the IF frequencies that this device can deal with. Interestingly, and I wrote that on top, it also supports RF groups, so that are the generic IF type of measurements, and actually I care most about that probably when it comes to the support of this device. I don't know exactly how that is going to happen. We need to find out, because if you look at the IF frequency, it is specified that it is able to deal with IF frequency between 7.68 and 15.36 megahertz, but this is as per the standard that it's running, so it switches between a number of different IF frequencies depending on which particular standard you're using. I don't know exactly what the IF frequency is going to be if you use it in a more generic RF group type of mode, but we'll find out in due time when we got the unit running. Also interesting is that Rohde & Schwarz claims that installing this unit has no impact on the measurement. The device will be recalibrated, and I think it's going to be written into EEPROMs into the device what the recalibration values are, and having this in the signal path, even via the bypass options or via the other options, should not affect basically the accuracy of the device. So it must be very precisely built here. And the last thing that I want to highlight here, just to manage expectations, installing this card does not provide you with any additional measurement modes or software. You just get kind of the hardware I/O type of thing in terms of what measurements the CMU itself can make. You just got what was already there. So you might be aware of the, for example, the IQ constellation diagrams and the eye diagrams, all that other stuff. These are already part of the CMU when at least you got specific standards type of things installed. Unfortunately, it's not there when you're just running it in generic mode. You get no more, no less. The only thing you get in terms of user interface is actually specific screens where you can choose the whole routing of the interface. So just that you get all this additional hardware I/O, but you don't get specific measurement options or modes that are available, that not will be available if you don't have this hardware on the machine. Now, since I already touched upon routing a little bit, let's take a closer look at that, because that is kind of the important part here. How can we use this unit? So somehow this unit goes in the signal path between basically the RF part of the device and the digital part of the device, where the information is being coded and decoded. So it is basically lying somewhere in the IF path. Now, as you can see from here, and this is a picture of the routing of this unit, and this is also the picture that you will go and see on the screen, and everything runs well when we can see like how all this different routing going on here. So you have a couple of different options, and let's quickly look through them. Well, first of all, you can have the bypass mode. This is where the device might probably spend most of its life. Anyway, you just bypass the unit altogether, and the unit is as if this is not installed. Secondly, you can choose a bypass mode that where you got an output of IF signals, where you can monitor them. So you see it actually takes a slightly different routing through the device already, going through a couple of additional switches here. The internal signal path is still the same, but you get the IF, at least on the transfer chain, you get the IF signal at the relative output. Secondly, you can get that IF signal at the relative output, but also input your own IF signal back, so you can have something there in between, a device on the test or whatever functionality you need there. So in this case, you interrupt the IF path, or you insert, if you wish, something into the IF path. Yeah? Then we got a little the same thing going on when it comes to IQ functionality. And as you already see the two little blocks below, there we have IF to IQ interfaces and IQ back to IF interfaces. And what we can do there is that we get simply IQ monitoring. So we get a signal on the IQ out there. And of course, I've drawn two lines there because you got an I signal and a Q signal. Now you're merely monitoring those. But you can also interrupt or insert, if you wish, in the IQ channel. So IQ comes out and you send your own IQ in. And this is particularly useful, I think it was devised, if you want to do things like fading analysis, where you would have a signal fader in between, or where you would kind of impair your IQ channels, for example, by rotating them or adding noise in one way or another, or reflections, or all type of different stuff, etc. And then we also can have kind of this scenario of RX insertion and IQ insertion at the same time, and actually quite a lot of more combinations. And everything that I just told you about, you can also do on the receive path, on the RX path, but I'm not going to repeat all of that because it's almost similar, I would say, to what I've just been explaining. So routing wise, this is a really flexible device, really allowing you to decide how you're going to put how you're going to put these inputs and outputs into use. Now, how are these in and outputs presented to each other? Well, they're going to be on the back panel of the CMU here, and on the back panel you're going to have a couple of additional connectors. I'll show them right over here. You're going to have 4 additional IF connectors. These are actually new. They have to be mounted into the device when you insert it. And you're going to have the IQ information basically on a 15-pin sub-miniature D-bus type of thing. That connector is actually already there, but only gets activated once you have the IQ board inside. That's where your IQ signals will appear, and to make good use of them, I already prepared myself a little breakout box. It's right over here, and it's simply got 8 B and C connectors for the various IQ in and outputs, and it got a 15-pin D sub connector. I think it's high density on the back. This is actually the same connector as being used for VGA, so you can basically just take a VGA cable and use it to connect to this device, and then you actually get all the in and the outputs. Should you be doing like very precise type of measurements, then you probably don't want to do this type of stuff how I did do that internally, but you might make your dedicated cable with specific shieldings to that port right away. But for the type of experiments that I want to be doing, this breakout box is going to be perfectly fine here. And as we are used from Roden and Schwartz, we get very specific information about all the in and output signals and their specifications, like the maximum value, frequency, well, impedance 50 ohms for this in all circumstances. I took them here from the various parts in the Roden and Schwartz documentation. Also here you see that in the RX path and in the TX, the transmit path basically, you see that it can switch kind of to different IF frequencies, again depending on the type of standards that you're kind of dealing with when you are using this device. Now as a next step, we got a visitor again. How are you, Kiku? Yeah, you're going to take a look? You can't touch this. That's not interesting, huh? Okay. Now I think we're about ready to go and install the device. One particular challenge is that I don't have any specific install instructions for this unit. Probably there was like a specific documentation kit that once came in, and a couple of little stickers and everything, and the cabling, of course. I do have the cabling, fortunately. That must have been kind of the original setting when you bought it. It did not come with a unit I bought from eBay, and I searched through the internet, and I think I searched pretty well, but it seems nobody has the original piece of documentation. I do have some notes from the seller of the device what pins I should be connecting it to. Additionally, I kind of expect that we might need to run a firmware update of this particular device, and we might need to run some calibration routines to get everything set as it should. But let's find out on the way and go along and try to install now the IQ module into the CMU. Now the time has come to try to put the IQ module inside my CMU here. So I already took off the outside cover, and then we have to take off this top plate here in order to get to the part where the modules goes in. If you already have worked with a CMU, then you probably know that this is built as a tank and also heavy as a tank basically. Yeah, now the cover plate comes off. And yeah, so this unit is fairly packed already. We got the TX-RX board, we got some signaling units here, the reference board over here, there's the audio board all the way here to the right, and much more of course. And the IQ unit should go over here in slot 5. So this is slot 3, and all the connectors on slot 3 are with X, so X32, X34, X35. This is 4, this is 5, that's where the new unit will go, 6, and so on. So on the basis of the information that I got from the seller of the board, yeah, it's right over here. I made a little overview what the current connection would be before we start to change anything about that. So let's go and check that. So I'm going to check board 3 here, so connector X37 should go to X708. So X37, that is over here, and this was together, by the way, by a tie wrap earlier. I already took the tie wrap off a while ago. X37 goes to, here it is, X923. Wait, that's not X923. No. X39, that is the most left cable, goes over here. We got no description here label on it. Oh, but we got it on the cable. X706, that is correct. And the 08 cable here, or actually the last cable here, existing cable, that is from the 7 board here. So that was the board we were just looking at. It should be 703. Let's locate that. 705, 704, 703. That goes down here and that goes here all the way. Yeah, I can see it, and it goes to the reference board. Yeah, I trust it. I'm not going to look up the number. But I'm a little bit confused because this wiring scheme of the existing configuration is not a wiring scheme of the device that I got now in front of me. So let's stop recording here and let me go and figure out why these things are not identical, and see what the next step is. Yes, I'm back, and figuring this out took me the best part of the day actually. So what's going on is that actually, because my unit has a signaling unit here, like many of these units, the signal is routed to a signaling unit and back, which is not so much a problem in itself, but then the question is exactly where does the IQ analyzer go? If these things are basically daisy chain, does it come before or after in the chain? And I mean, trying to look up some information, it was not that many, but actually some very useful information is here on the back, on this cover plate here, which is actually a pretty hard to read thing. I made some pictures of it, made them bigger. And there we can already find some clues to what the right configuration of the device is. On the basis of that, I've drawn an overview what steps I should be taking basically to include my new interface. And I also made a stepwise description here for each of the wires that I'm going to replace here. So if we quickly look here at what the configurations are, on the left hand of the screen you see my current configuration, and it's, well, pretty similar to the earlier one, only we see there that there's the B-17 baseband board, which is indicated as A9 on the left, and that one is between the chain. As you can also see here, I added here some coding, W17, W19. So these are basically the wire codings that are used on the device here. Often they align in some way to the originating plug here, but not necessarily so. So you have to take a bit care with that. And I also figured out on the basis of information that I now have what the configuration should be with the IQ card installed. So it kind of goes in between. Before the baseband board, a number of cables have to be rewired or added as new cable. Some of the existing cables are going to get like new names in the nomenclature of Roden and Schwartz. So W17 is becoming W522, for example. That's all fine. But some others like W33 do not get a new name. While you would expect that would get a new name W501, I guess. I don't know exactly what decides here, what's the deciding factor. But this is the way that, that Roden and Schwartz has himself used the indicators here. So basically this is the overall plan of how I'm going to change things, and mind the colors that you see here of the wires. A red wire is an existing wire that's going to be reused, so rewired. A blue wire, that's a new wire to be added. The green wires, that are the wires basically to the BNC connectors on the back panel. So they are, I got them with with the module that I ordered and the pigtail cable, so they come with BNCs. And the IQ signals themselves, actually you don't have to wire anything, they will go via the motherboard down there with this large, I think 96 pin connector or well, sometimes even more, 2x90 pin connector, and then they will arrive at the D-sub connector all the way at the back. So we don't need to do anything there. Interestingly, there's also another output connected to X500, which is reference-free output, and it says normally not used. But I got some ideas what information might actually be there, and then I might care about that, so I might actually go and make a cable for that. And as a final note here, when I was double checking for the second time all the information that I had, I noticed that there was actually another cable to be connected between the new board and the baseband board, which is cable W914. It's easy to overlook that because it doesn't kind of have a equivalent in the old configuration, but that's another cable that you have to add to the set. So this should be the entire rewiring of the unit. Yeah, so let's go. It's a stepwise process. Let me go and get the board. And I'm going to do all the steps one by one and probably put the video in a fast mode so you don't have to spend hours basically listening to what I'm doing here. Also got a whole load of old connectors here, whether I might take them off right now or I might exactly see step by step how I'm going to do that with the old connectors here. Anyway, here we go. All right, I took all the existing connectors off. I thought it was going to be a little bit easier, and there's a kind of a connecting thing. Let's see if I can put this in without having to remove the existing wiring. That might not going to happen. Okay, the card is in. I had taken out cards before of a dummy unit, but there were several wire wraps in the way that I had to remove. There was also this little dust cover that I actually had to screw out before the card would actually go in. The funny thing is that the cards are like all of metal, but there's actually the PCB that is hanging in, like in a PC with a ISA or a PCIe card or so. That's kind of funny because everything is such a heavy metal construction. But anyway, now I build it back just to the way it was before the unit was in. So now we can start a rewiring process. Now I double checked, I think all the wiring is okay. I'm now going to start up the unit, and first I'm curious to see whether in the startup screen we will get to see that B-17 is recognized. Let's be a bit patient. We get the software version, the lab test. B-17 available. Yeah, so we do see that the device recognized it. There's still a couple of steps to take. It should be provided with the right software, and it should be calibrated. But this is a good first step. As this unit is fully loaded, it's taking actually a while to boot. My other CMU200s boot considerably faster. Now, out of curiosity, let's go to Connect Control, IQ. Oh yeah, now we get to see the new menu. I haven't seen this menu before. Ah, wow, this is cool. We see all different switches being made. But now we're still on the regular type of path, the bypass path. And now we get like all these other kind of combination that we can program into the device. Now, let us see first if we have to provide a new firmware version. And in order to do so, I would first like to see what version the device currently has. So B-17, it just says available. We don't get to see the version number. Let me check out whether with info we get something more. IQ interface board. Oof. Okay, interesting. So apparently there is no specific software version associated with that. Well, this is a part number and a modification index. I would like to know if there's a specific software version associated with it. The modification index might actually be that. That might be the firmware, but maybe there is no firmware for this device that is relevant here. The calibration part, so we go to the calibration menu, and here there's an IQ self-test. I think that's the one we're going to run. It's on program. I think it finished successfully. So we didn't have this before, but it tested the APROM. We got some voltages, that seems okay. Everything is apparently within range, otherwise we would get error messages. So there's a self-test that has been run properly. Let me see if there is also a B-17 calibration that we need to run. No, I think that's it for now. Okay, things have been not going so well, because since I have installed the card, what I basically see is my applications don't run well. If I start to an application like here, the power meter, I don't see anything. I very quickly see here the input LED, and then it stops again. And I have that same problem across various type of functionalities. Some things seem to work. And now it even seems to hang. Yeah, that is definitely not good. Hanging all together. This actually never happened before to my my CMU, so this is bad news, I would say. Okay, now I had to stop recording because everything started to go wrong here. This is a kind of a grand failure. I didn't get the IQ module to work, and I don't think I took videos of all the different things that went wrong at that point, because I just got too upset and was looking for solutions here. So maybe I should end this video by doing a bit of diagnosis and problem analysis here. Well, first of all, the good thing is that the IQ module is recognized by the system, and the IQ module passes the self-test stages. So something seems to be good. What I didn't expect, but what I see is that if I look at this unit in contrast to all the other kind of advanced units inside, you don't get to see, if you go to system setting page, like a specific version number or any other information. I have kind of the impression it is a kind of a dump unit that just has this switching inside or so, no more than that. Related to that is the first point of failure. The loop test, the external loop test from channel 1 to 4 and channel 2 to 3 all fail now on the device if I get it to run. This is not surprising in a way, because my IQ module has not been calibrated into this device, but I don't know where to calibrate it. For other types of calibration in this device, and let me now go back to a sheet that I made for a earlier video about the CMU self-test. Have we got a whole set of calibrations going on? Hey, hi there. You're coming back again. Nothing to eat here, huh? And it doesn't even smell good. Yeah, too bad. Yeah, let's not get distracted. So for other users, like you see here, the audio board, FM modulation, correction filter, calibration of the downlink CDMA, wideband CDMA module, for the signaling unit for CDMA 3000. We got calibration routines that we can just start from the self menu, but there is nothing as such for the IQ module. So I don't know where the calibration is, to be honest. So okay, I'm a little bit stuck in there. The IF outputs that I've looked on the BNC connectors, I don't seem to see the right signals there as well. Much more disturbing even, and something that got me stressed, that the CMU starts to behave in an unpredictable way. It fails to start applications in measurement mode. So what is happening if I go to a application, and normally it's already running when you go to an application, but it's stopped or halted, and when I try to put it on, I just see like the generator light at the RF port just going on and off for a second, and it stops again. That doesn't look good to me at all. I've never saw it behaving in such a way before. Something is wrong. It's not able to start up the application or so. And even worse, the CMU starts to have crashes. When I'm in measurement mode, it crashed a couple of times, even trying to boot itself. Yeah, so it really doesn't look good. At some point I decided to try to take out the entire unit again, the IQ unit, and rewire the CMU back to original. And fortunately, after doing that, it runs again. So nothing seems to be broken for now. But I don't know exactly what is going wrong when I'm installing the IQ module. I hope to be able to come back to this if I make some progress on trying to locate down the fault. And if you got anything, then of course do share it with me. I'm happy to learn from others that might have been through the same type of issue here. Anyway, that's it for now. Not such a successful video, I'm afraid, but I thought I'm going to share this anyway. Should people, try to do the same exercise as I did. And I hope the next time on my channel I have a bit more of a positive type of video. Thanks for watching, and do subscribe if you enjoyed this video.